We are still busy with factorization, and in this video we are going to practice factorizing trinomials. We have got two types. We've got two types of trinomials, and in this video we are going to focus on type A. This is where A is equal to 1, and I'm going to show you what I mean by that in a moment. And then for type B in the next video, we are going to look at where A is bigger than 1. Let's copy over this form over here. So a trinomial is an expression with three terms, and it's often in that form. Let's just talk about that form before we do any factorizing. So any expression with three terms cannot be factorized using this method. I'm going to show you the kind of the pattern that it needs to take on. So when they ask you harder questions, you will be able to identify if it is or not possible to use this method of factorization. So if we think about this, let me just use something else there. Ax squared plus bx plus c. There is the standard form or the desired form for a trinomial that we can use this method of factorization. Our coefficient there, our coefficient or our leading coefficient or our coefficient of our x squared term is our a. Our middle term or our coefficient of our x term is b, and then our constant term is c. So for example, if we write down 2x squared plus 3x minus 5, for example, then there we've got our a value is 2, our b value is 3, and our c value is negative 5. So that is where this a comes from, right? So in this video, we are going to focus on factorizing trinomials where the coefficient over here of our leading coefficient is 1. So the coefficient of x squared is just 1. That's the most basic, and we're going to start with that. Let me just show you the pattern that it needs to take on. So if we've got something, whatever it is, a x squared plus bx plus c. Let's just focus on these. So there is my x squared and then my x to the power of 1. That is in the right form. But what about this? X to the power of 4 plus bx squared plus c. That's also in the right form. See if you can spot a pattern there. A is equal to x to the, a times x to the power of 10 plus b times x to the power of 5 plus c. It's in the right form. And the next one is, I'm going to write that it's not in the same form. X to the power of 12 plus bx squared plus c. That is not in the right form. We can't use this method of factorization that we're going to look at right now. So what is the pattern? Whatever you've got over here, the middle term must be a square root of that. So there, if I've got x to the power of 4, the square root of that would be x squared. So it's the right form. X to the power of 10, x to the power of 5. Yes, because if we get the square root of x to the power of 10, it is x to the power of 5. So then it works. But it does not work for this. So we won't be able to use this method of factorization that we're going to look into now if it's not in the right pattern. So what I'm also trying to show you there is that any expression with three terms is not a trinomial that we can factorize using this method. Okay, let's look at our three examples. First one, is it in the right form? Well, we've got our x squared and our x. There's three terms. Yes. So it is a trinomial that we can factorize. Let's identify our a and our b and our c. Our a is equal to 1, so that's our type A trinomial. Our b is equal to 3, and our c is equal to 2. All right. So if we write it as a product of its factors, we're going to land up with our two sets of brackets. Those will be the factors. Firstly, in the brackets, we're going to have the square root of our x squared term, which is x, and that works because, if we just FOIL it out, that's how we're going to get back to that x squared, right? Okay, so then, how do we determine what goes into the brackets? We are going to take our c value. We are going to take our c value, there it is, and we are going to find its factor pairs. So 2 can be written as 2 times 1. Boring example because there's literally just one factor pair, but that's okay. It's a good start. Often when you've got a number like, for example, 80 or 48 or whatever, there's obviously more factor pairs that we need to consider. But what are we going to do with these factors? So we need to decide, okay, how can we add or subtract these these factors, so that it gets us back to our middle term of positive 3. So if we have plus 2 and we add another 1 to it, it will give us 3. So that is what's going to go into our factors. Plus 2 plus 1. And if we FOIL it out, you will see that we get back to that trinomial where we started. And then we factorized it. Let's look at the second one. For the second one, is it in the right, or does it take on that pattern to use this method of factorization? We've got y squared, y to the power of 1, and then a constant term. It works, so we'll be able to factorize it. Our a is 1, so that is in place. It's always a good idea to go check and see if there's a highest common factor that we need to take out first. Do keep that in mind. So we've got our a, we've got our b, which is -2, and then we've got our c value. All right, now what are we going to do? We know that it's going to break up into our 2 sets of brackets when we're writing it as its factors. We're going to get the factor pairs for 8. Don't worry about the sign for now. It will be 4 and 2 and 8 and 1. Now let's have a look and see. How can we add or subtract those factor pairs so that it gets us back to the middle term of -2? So if we look at 8 and 1, there's no way how we can add or subtract them to get back to -2. It's just not going to work. Let's look at 4 and 2. So if I've got -2, no, that's -4. And if I add 2, that will get me to -2, which is my b value, my middle term. So that is what's going to go into our brackets. So the square root of y squared, which is y, and then that, and that. It doesn't matter which one goes into which bracket, and you'll see if we FOIL it out, it's going to get us back where we started. Last one. We're going to have to just write that in like the desired form, where we have our square term that's first, and then we have that is our middle term there, and there is our constant term. All right, so we just kind of just rewrote that and moved that order, or changed the order around a little bit. We don't want that -1 coefficient over there. That means that we have to take out a common factor of -1. -1, we don't have to write the 1. I'm just doing it for this example. Then we're going to land up with that. We're going to land up with that. And we're going to land up with that. Now, this is the desired form that we want to be able to factorize this trinomial. So it's x squared, x to the power of 1, and there's our constant term. Great. So we can use this method of factorization. Now our a value is 1, our b value is -2, and our c value is -15. All right, so we're going to factorize that. Don't forget about that negative in front that we need to tag along. And it is important that we take that -1 out. What are we supposed to do? We are going to take the c value and we are going to get its factors. Don't worry about the sign. 15 times 1 and 5 times 3, and that's all. All right, now let's have a look. We need to see how can we add or subtract each of those factor pairs in order to get us back to the middle term of -2. Well, 15 in 1 is never going to work because it's too big. It's never going to get us back to -2. But what about if we've got -5 and we subtract, and we add 3? That will give us -2, which is our middle term. So it means that that needs to go into our brackets. So let's do that. The square root of that x squared is x and x, and then we've got -5 plus 3 that we got there, that we're using as those factors, and then it's factorized. You'll see if you multiply all of this back out, FOIL it out, then you're going to get right back where we started. We're done. We factorized it. We wrote it as a product of its factors. And that's it. In the next video, we are going to look at how do we factorize this when your a value, your leading coefficient, is bigger than 1.